Discovery, go at throttle up. Discovery, go at throttle up.
It's time. It's time. Let's roll. I didn't sleep.
Discovery, go at throttle up.
I didn't sleep. Disregard your text. Faraday cage, man. I didn't get any text.
Discovery,
Are
go
you
at throttle up.
packed? Oh yeah. Oh yeah. I didn't get much sleep, dudes. But also the bits and the subs, dudes. Ugh. Oh.
A Jacksonville
Discovery, go at throttle up.
tracking plane that NASA uses for these special occasions, especially for example.
All right, these are our buddies over at NASA Space Flight. We're solo today. Oh, Meeps with the
Discovery,
raid.
go at throttle.
Oh, damn. Meowdy. What's going on? Oh.
Discovery, go at
So,
throttle up.
welcome to our coverage here of the IFT-2 mission. Starship Integrated Flight Test
Discovery,
2.
go at throttle up.
Biggest rocket ever made. Won the Academy Award for, biggest rocket ever made. And we just got rated by Mr. Meep
Discovery,
Skitten.
go at throttle up.
What's going on, man? Ina, 22 months, and the sub alert is going off like crazy. Figured this would be the best way to wind down after stream. I wind down. Okay. I don't know about you, man. I could wind down. I couldn't sleep. I couldn't sleep because dreaming about this thing. How do you feel about Vegas now? Question. I don't care. Do you see that? This thing right here makes Formula One irrelevant right now. Irrelevant. Starship. Anyway, Neeps, thank you very much for the raid. I do appreciate it. It's good to see those numbers up, dude. That's cool. Very cool.
Discovery, go at throttle up.
2020, hey, what's going on? Sidley with the 44, Emon Demon with the 55, and many more. Thank you very much. Oh yeah, see that's the reason. That's the reason why we had. That's the reason. Oh yeah. Oh yeah. What's up, PY? How you doing? Yeah, it's terrible, Thorin, I know. Just wants to give it a hug, that's right. It's Vice City. When is the launch? Alright. So the launch window opens up in about 47 minutes, top left corner. Oh boy. Oh jeez. This is awesome. This is awesome. I need more coffee, man. Oh man. Is Starship gonna do a hot staging? Yes it is. Yep. Your mother is a 737 pilot? F1? That's cool, man. Oh, excuse me. I'm still waking up, guys. I did not get much sleep. Dude.
Discovery,
So, this is a live shot from our buddies over at NASA Spaceflight. SpaceX did tweet a little while ago that they are good for prop load, so... Addicted to Microsoft Flight Simulator. That's fair. Yeah, Finnick, that's fair. Hey, Ram Pratt, what's going on? At work watching stream on the phone. Why is it venting? Right now it's venting because they're filling it up with propellants. And when you fill it up with, they're commodities is what they're called. They're filling oxidizer and methane. When you do that, you're putting liquid into a pressurized system, right? You got to take some gas out, or else you can overpress the tanks during cryo loading operations, during commodity loading operations. So there'll be some terms being thrown around here. Commodities is the word for propellants, so fuel and oxidizer. This is the commodity farm or fuel farm right here. On either side of the fuel farm, there is the heat exchangers that supercool the propellants, basically make the propellants cold because moving them around warms them up. You don't want that. Clearly, both heat exchangers are on, indicating that they're loading. That is the super heavy methane tank, right? And you can see the ice forming on the side of the booster. The ice forming is because when you put the cold propellants inside of a metal rocket, the metal, basically loses heat. All the heat goes out, and it actually gets really cold, right? It gets so ridiculously cold that it condenses the water vapor in the atmosphere around it. Basically, the same kind of phenomenon going on if you have a cold beverage, you have a cold snack. Oh, time to wake up. I didn't need that alarm. Nice. When you take like a cold beer, cold beer, take it out of the fridge, cold snack, and it sweats a little bit, same idea. Same thing, only much colder. Don't lick it. That's what I'm trying to tell you. Don't do that. Are you watching the SpaceX feed when it goes live? Yes. Yes, I will. If the hot staging ring fails, is the booster holding the ship hostage? Go away. Just No, it's too early. It's too early, man. It's too early, dude. Please. Please, don't lick the rocket, okay? Morning, everybody. Do not hump. Do not hump. Is there people on the spaceship? Finnock, this one does not have people aboard. This is a test flight. The purpose of this mission is to make sure that this thing works. They're going to try to get it into space. If they do get it into space, Super Heavy, the first stage, is going to come down and propulsively do a landing out in the Gulf of Mexico. And Starship is going to do one orbit, well, not even one orbit, around, and it's going to land out in the Pacific Test Range near Hawaii to basically test its heat shields and make sure that the heat shields work. If it does launch, we're in for about a 90-minute mission. Yes, I will be here for all of it. Yeah. I wouldn't miss this. Fortunately, where the launch window ended up being with Starship, it ended up being in a time, this view from South Padre Island, and it ended up being at a time where I actually, if I got up early, we could cover it. So I'm super happy about that. My flight doesn't leave until late afternoon, so we are good to go. You've had enough puns from Zoyer. Yep. Where are you headed on the flight? So, Dino, I'm going to be down in Florida at the Cape. Believe it or not. I'm going to be at the Cape
Discovery,
for a week.
throttle up.
Wasn't, you know what? The weird part is? It wasn't even my idea. Brimo's family wanted to spend Thanksgiving in Florida, so... Alright. We did. I mean, we usually alternate, so... This year, it's Thanksgiving with Brimo's family and Christmas with my family. Right? Next year, it'll be vice versa that. And they said, instead of coming to Detroit, we should go to Florida. We should all go to Florida. And I'm like, where? And they're like, oh, Daytona. I'm like, guess what that's near? Guess what that's near? That's near the Cape. So I'm like, oh, geez, don't twist my arm. Oh, no. Yeah, there is, drummer. Yes, that's right, Tessa. That's correct. Yes, yes. All right, we're inside of 45 minutes here. Oh, man. So, prop fill on Starship. They have methane and liquid oxygen in the second stage there. Starship is fueled by this thing right here. This is the SQD. This piece of equipment right here. It's called the Ship Quick Disconnect. Bisquick. Now I'm hungry. This is called the Ship Quick Disconnect. Got it. When Starship goes to launch, the SQD it'll move out of the way. Bisquick. Will you be covering any of the launches perhaps in real life? It's vacation, Blue, so no guarantees, okay? But yeah, I'm going to be gone for the week. The next stream after this one will be on the 27th, unless there's an IRL stream. You think the 737-900 is a nice plane to look at? I'm a 737 fanboy, Fanuc. I like the 747 better, but who doesn't? Quick disconnect. Yep. Nailed it. Triple Seven gang. This 777X is
Discovery,
a nice airplane. Phantom Man, you're on a 757 right now. Also a nice plane. You prefer Nesquik to Bisquick. Oh, okay. Nice, Putsbert. There you go. Shahan, yeah. Good luck, buddy. Good luck with that one. They kick you out yet? Jeez. Is it bannable to say beluga over the Dreamlifter? No, it's not. It's just we'll judge you a little bit. And by a little bit, I mean Okay. No. Oh, yeah, baby. I'm disappointed in you, Dishrag. You like that? You guys like that big Texas sky? It's pretty good. What would be considered a success if the first stage and the second stage? What's I don't know what that. Okay, those are some people. If the first stage and the second stage both make it back down in one piece before they hit the ground and hit the water and decide to not become one piece. That's that big Texas sky, man. It's absolutely a thing. I seen it. First Formula One race in Austin was the first time I ever went to Texas back in 2012. And I saw the big Texas sky, and I'm like, oh, that's what they meant. Okay. Damn, that's pretty. Also an intact launch pad. Yeah, see, mission success here would be to not have anything on the screen right now explode. We don't want that. Yeah, we don't want that. No Kerbal flips would be a good start. Yes, yeah, like what happened last time. The last time they went to launch was April 20th, wasn't it? IFT-1 was April. Yeah, it was.
Discovery, go at throttle up.
No rock tornado. Hey, Shinar. What's up, man? Why the sunglasses? It's an old tradition, man. It's bright outside. Nah, it's old thing. We'll put them back on during the launch. Or maybe, I don't know. Something. He has eyes! I think you'd lose it if it lands in one piece. The Starship is not doing a propulsive landing. It's just going to belly flop into the water. But yeah, that would be pretty cool. Can you please check the SpaceX YouTube channel and tell me they aren't got hacked? SpaceX doesn't broadcast on YouTube anymore, Molly. If you see somebody broadcasting on YouTube as SpaceX official, that's nothing. That's somebody trying to clickbait you. SpaceX broadcasts on X exclusively. So, yeah. No one's hacked SpaceX. They're just clickbaiting you. Why is liquid oxygen is shown on the top of the methane in the last stage? What? So you have methane, so you have your header tanks up there, methane and oxygen, or actually oxygen, methane for the header tanks. That's for mass distribution. And then you have methane and oxygen, methane and oxygen. These two up here are called header tanks.
Discovery,
that's there to basically balance Starship, balance the fuel around Starship when it goes to, hey Airborse, when it goes to do this. That's for landing purposes. Now, we're not going to see that exactly today, but close. SpaceX is online. All right, dudes. Here we go.
Discovery, go at throttle up.
You can blame the mods on that one, Ebsta. It's gonna, yeah. Brendel, this one's gonna get to, if, you know, Jeb willing, it's gonna get to space. Oh, man.
Discovery, go at throttle up.
Freaking unit, man. That was footage from the first flight.
Go and throttle up. Discovery, go and throttle up.
Let's roll. They will, Rothran, yeah. Yes, Han. What's up, Greg?
Good morning, Star People. On your screen is a live view of Starship awaiting
go
its
over here.
second integrated flight test from Starbase, Texas. If all goes well, our Starship spacecraft and the Super Heavy booster, which we collectively call
Dude.
Starship, will lift off together for
Dude.
the second time in just 33.5 minutes from now. Thanks for tuning in. We're excited to be joining
Kate
you
and
from
Shiva.
SpaceX headquarters in Hawthorne, California for today's flight test. Now, there's nothing quite like launch day, and especially so when it's a test flight. It just hits different. We're super excited to be here.
Exactly, Kate. And we're excited to be here to watch Starship, which is the latest and largest vehicle developed to date by SpaceX. And we're building it to fly exciting missions, to get massive payloads into orbit, to land astronauts on the moon for the first time in 50 years, and ultimately to get humanity to Mars.
But the fundamental revolution with Starship is that it's designed to be a fully, rapidly reusable, reliable rocket, or what we refer to as the 4 Rs. For those of you following along, you know all too well
Not
that
1 or
Starship
2 or
gave
3,
us
but
quite
4!
a show during
4
its first
Rs!
flight test back in April. After
Hey, Jungle,
successfully
thanks, buddy.
lifting off and clearing the pad, Starship became the most powerful rocket ever launched.
But during the ascent, we had leaking propellant in the bottom of the booster, which led to sustained fires,
Integrated
loss of
flight test
control,
drama.
and ultimately a rapid, unscheduled disassembly. Of course, there's no test quite like a flight test, and our teams learned a lot, which began design changes and then ultimately hardware upgrades. That iterative approach is a big part of how SpaceX does development,
It's a
and it's
freaking
been the
monster,
basis
Zero.
for all of our major innovations, including those on Falcon, Dragon, and Starlink.
I have to comment what gorgeous sunrise
Hey,
views
boss.
we have here of Starship.
Freaking cool, man.
Now, while that
This
first
is
flight
awesome.
ended in
This is so
fireworks,
good.
it delivered valuable test data, which our teams have used to rapidly iterate on Starship's overall design, including significant upgrades to the ship, the booster, and the ground systems. Now, the most notable change is to the stage separation
Discovery,
system,
go and
which
throttle up.
will also be the most challenging part of today's test. We'll talk a little bit more about those updates a bit later in the webcast.
Now, in preparation for today's
not
flight
yawning.
test, the vehicles have undergone dozens
Coffee.
of individual tests, including a static fire on the ship, 2 super heavy static fires, and a final full wet dress rehearsal that we completed at the end of October, where we loaded the vehicles fully up with propellants and tested our new countdown sequences. And that brings us to these beautiful shots on today's flight test
Dude.
day. After 7 months of hard
One
work
hop.
by the entire SpaceX team, we're ready to give launch another shot.
One hop.
100%.
Excuse
now,
me.
once again, just like Flight
One
1,
hop.
excitement is in the air. The electricity is certainly starting to grow. This is a live view of our Starbase Control Center, known as Star Command. It is 6 miles from the pad.
Star
we also
Command.
have teams gathering here,
Okay.
right behind us in Hawthorne, California, at our Mission Control Center.
Yeah,
You can see the
baby.
crowd gathering. It is an early morning, but you got to wake up early to get that front row seat. And we also have public gathering on the beaches at South Padre Island, as you see there.
And I
Okay,
can't say this
video.
enough, today is a flight test.
Yeah,
While it's
that's
not
on purpose,
happening in
man.
a lab or on a test stand, today is absolutely
Why
a
won't
test.
you answer?
And the goal is to gain invaluable data to continue rapidly improving Starship. So whatever the mission outcome
Dude.
today, excitement is
What a
guaranteed.
shot.
Now, if all goes well, Super Heavy will fire its 33 Raptor engines and lift off from that pad right there in Starbase. About 3 minutes into flight,
Watch.
we hope to see the Super Heavy booster separate from the ship in SpaceX's first ever hot stage separation. This means that the second stage will light its engines while still attached to a partially lit booster. If the ship's engine's light, and if the whole thing holds together, its engines will remain lit for about 6 minutes before the coast phase.
Now, with those big ifs, if we get past a successful stage separation, the booster is going to perform a flip maneuver, then execute a boost back burn before it attempts a splashdown in the Gulf of Mexico. In the meantime, Starship will coast for about an hour at altitudes ranging between 150 and 250 kilometers before it makes its own re-entry into the Earth's atmosphere, and then ultimately a hard splashdown in the Pacific Ocean.
Now, again, if we get past a successful stage separation, Super Heavy will leave the ship at an altitude and trajectory just shy of orbital, meaning Starship won't have to fire its Raptor engines for a deorbit burn and will naturally come back into the atmosphere. Now, meanwhile, Super Heavy will attempt a landing burn before splashing into the Gulf. While the booster will practice a landing, we do not plan to recover any hardware from Super Heavy or the ship on this particular flight. Now, with the exception of Falcon, this really is no different than what happens to most other rockets flying today that are expended or fall into the ocean after completing their mission.
Now, even though we aren't planning recovery, the telemetry and data that we receive all the way to the end of today's mission is really what we're looking for, particularly with respect to temperatures during re-entry and how the heat shield performs. Much like our first test, we want to gather as much data as we can around the fully integrated vehicle in this flight-like environment.
Exactly. So let's talk about some objectives for today. The primary goal for Flight 1 was to clear the pad. We did that, and we got amazing data that helped us to improve the vehicle and pad that you see right there today. This time, on Flight 2, we're hoping to get all the way through stage separation, where we will try to perform this hot staging maneuver. In the bigger picture, ascent is the most critical objective today, and everything else is learning. Like I said last time, a few times, the further we fly, the more data we can collect.
Now, we do expect that the camera views will be spotty after stage separation, and that's because we rely on ground stations that are positioned along the globe along the trajectory. But we are experimenting with Starlink on both the booster and ship on this mission, which will be communicating with our satellites in orbit to see if we can get that data.
Yeah, so if we make it past stage separation, there is a chance that we could get better live views throughout the duration of the flight test, including re-entry, where we typically have a blackout period with no communication with the vehicle whatsoever. So all that said, this is the first time that the vehicle will attempt to communicate with Starlink in orbit, so no guarantees.
That's cool,
now,
man.
We're at
See?
Starlink
antennas are built into this one.
John for an update on the countdown. How are we looking, John?
John!
We're currently loading propellant from the ground system into both the first and second stages.
Yes!
And we're on schedule for launch in just over 26 minutes from now. Now, we delayed a day getting here. Yesterday, on Friday, we had to replace a discrepant grid fin actuator on the first stage. We also replaced 2 other actuators as a precaution. The stages were remated, checked out, and everything was go for where we are right now this morning. Now, as I mentioned, we are in propellant loading. Both vehicles, the first and second stages, use the same 2 propellants. Our fuel is liquid methane at a temperature of just over 100 Kelvin, or about 272 degrees below 0 Fahrenheit.
Yeah.
This is a different
Kelvin
fuel
and Fahrenheit.
from Falcon 9, where we use the RP1 kerosene. But our oxidizer is liquid oxygen, the same as Falcon 9. Because there is no oxygen in space to support combustion, we have to bring our own. We did the weather poll and the go-no-go poll at T-minus 2 hours. We got the goes, and we started loading both propellants on the booster at T-minus 1 hour and 36 minutes. And at T-minus 1 hour and 17 minutes, we began propellant loading of the ship, second stage. Propellant loading of the Starship second stage main tanks will complete at approximately T-minus 22 minutes, just a few minutes from now. And at about the same time, we will switch over to loading the header tanks in the nose of the ship. Meanwhile, it'll be T-minus 3 minutes when Super Heavy prop load completes on the first stage. And at that point, all propellant will be on the rocket, fully loaded with over 10 million pounds of propellant. As we near T0, it's worth noting that the timing of the countdown will be slightly different today. For Flight 1, we lit the engines and lifted off about 6 seconds later. For Flight 2, we aim to reduce that time by almost 2 seconds, shortening the period between engine start and liftoff. This will help reduce stress on the ground and the propulsion systems and improve the efficiency of the rocket. Now, right now, we're just inside T-minus 25 minutes to liftoff. The weather and winds are looking good. We haven't had any concerns there. The only issue we're working is getting the
Noontime
small
make.
boats out of the near-range area in the offshore from
Discovery,
Boca
go and
Chica
drop.
Don't you
Starbase.
dare, boats.
We do have the possibility of holding at T-minus 40 seconds as we're trying to get the last of the boats out of the safety area. Now, if for some reason we do not make our test flight today, we have a backup launch windows. This could be either 24 or 48 hours after today.
No.
It depends on how far we get into the countdown. But for now, everything's looking good as we've passed, coming up on the
I'm good, Baron.
24-minute mark. I'll hand it back to you, Kate and Shiva.
Thanks, John.
Discovery,
Now,
go and
that
throttle up.
countdown is continuing to progress, so let's take a look at the and get more familiar with the vehicle there on your screen.
No.
Starship is the world's most powerful launch vehicle. It's currently currently with about twice the thrust of the Saturn V rocket, and with future
Discovery,
engine
go and
upgrades,
throttle
it
up.
will be 3 times more powerful. Those future improvements will allow Starship to carry 150 to 250
Thanks,
metric
Nova.
tons to orbit.
Now, for reference, Falcon 9's heaviest payload to date
Hey,
is
Bear.
about 17 metric tons. So we're talking about an order of magnitude more with Starship in terms of payload capability. And that matters because the amount of mass that we're able to launch per rocket is crucial to ultimately creating a self-sustaining city on Mars. Now, let's talk a little bit about how tall the vehicle is. The
Discovery,
Super Heavy
go and
booster
throttle up.
alone stands about 70 meters tall, and that's about the same height as a fully integrated Falcon 9. The height of Starship on top of it is comparable to that of the Statue of Liberty.
Any
But of
unit
course,
but
the most
metric.
technical length unit is that of Godzilla's. And we can confidently
See?
say that the fully stacked Starship and Super Heavy is at least one Mechagodzilla tall. It just so happens that we refer to the launch and catch tower at Starbase as the Mechazilla from the Godzilla movie, and you could see from that that the resemblance is quite uncanny.
Very, very uncanny.
Yep.
Now, the first stage, also known as the booster or Super
I'm fine
Heavy,
with this.
has a diameter roughly 2.5 times that of Falcon 9, and with 33 much larger engines. More engines means more power to deliver a massive amount of cargo to space.
Discovery, go and throttle up.
Amazing view here. This is a view that we don't have on our Falcon 9 missions. This is a view looking up under the Super Heavy booster. I love the shot. We can see all 33 engines there. Now, one cool upgrade on the booster's engines, we have a new electronic thrust vector control system, or ETVCs. We previously used the hydraulic system to control the positioning of the Raptor engines, meaning we tilted them in flight using pressurized fluid.
Passing. Yes.
Now, hydraulics are complex, and because they're fluid-based, they have the potential to leak. Not good. So, switching to an electronic
not
system
leak.
means fewer
You leak.
potential points of failure. Also, we now carry less mass on the vehicle because we don't need to carry hydraulic fluids anymore. So, good news all around. Now, the electric system has lots of benefits on its own. It only takes 30 minutes to activate for flight. It doesn't
Discovery,
consume
go and
resources when
throttle up.
inactive,
Ryoko.
and they allow for regenerative charging like a Tesla battery.
Yeah, all great things when
They
you're
probably
trying
are
to
Tesla
rapidly reuse
batteries.
the vehicle.
For-
Now, moving
for
up,
what it's worth,
Starship
they
is
probably are
designed
Tesla
for
batteries
vertical
in there,
takeoff
just
and
saying.
landing on any hard surface. That's opposed to taking off and landing on a runway like aircraft do. And that's important because there are no runways on the Moon and Mars. The ship features 6 Raptor engines, 3 of which are sea level, and 3 of which are vacuum engines with an expanded nozzle, which makes them optimized to operate in the vacuum of space. The ship, at the top of the ship is featured with 4 flaps as well. This is a shot actually of the top of the booster where we can see the hot stage portion and the 4 grid fins.
I see
Now,
you
the
got grid
flaps on the
fins.
ship portion help
I
aerodynamically
have grid
control the
fins, too.
vehicle's attitude during atmospheric reentry and flight, and will enable us to do precise landings. The body of Starship is also wrapped in a heat shield that's made up of 18,000 hexagonal ceramic tiles. You can see them wrapping around the top of the nose here and here in this shot of the flaps. Now, those tiles are designed to insulate the vehicle during atmospheric entry, where the temperatures can get as high as 1,500 degrees Celsius, And one of our test objectives today is to verify how those systems perform during reentry.
Dude.
Yeah, now as Shiva mentioned, there between the ship and
nuts.
the booster, basically the top of the booster, between those two stages, that's our new hot stage, critical for our new separation technique. As we talked about earlier, we are constantly learning and upgrading the vehicle after we test. Now,
is,
this is a
Ozzy.
pretty exciting first for our team,
Something like
as
that,
hot
Snickers,
staging
yeah.
has never before been used as part of a reusable space transportation system, let alone on a rocket with the size and power of Starship. Hot staging is a significant change from Flight 1, and we're really hoping to gather data on it during this highly dynamic phase of flight.
Engine
And
chill
that
down has
is, once
started.
again, assuming that we even make it that far.
Of course, let's take a closer look at what we expect hot staging to look like. Now, it occurs at about liftoff plus 2.5 minutes. At that point, the booster will shut down most of
damn
its
right,
33
Port.
engines, leaving just 3 running, and the ship will ignite all 6 of its engines. Clamps will release, and then the ship will thrust away from the booster. Now, this is the first in-flight test of the heat shield on the top of the booster and the bottom of the ship, and of course, the first in-flight test of hot staging, and we're hoping to gather a ton of data on it today.
Yeah. Now, stage separation by hot staging is somewhat uncommon in spaceflight, but it has been done before. However, today will mark the first time that a reusable space transportation system is attempting it. The Titan program
That's
did
correct,
hot
Super.
staging quite successfully in the early 1960s, but they were not concerned with reuse, so there was no issue when the Titan first stage took
It's simpler,
considerable damage upon ignition of the second stage engine. Now today, there is a good chance that our booster will also incur some damage from the second stage engines, but we need to test it out, see if the system can tolerate it, and collect data to learn how to do hot staging better next time, because ultimately,
getting there,
when
Ultra.
successful, it could increase Starship's payload to orbit capacity by 10%. So more payload and more people to Mars.
Right there.
Hot staging also helps us maximize the vehicle's performance by leaving those 3 first stage engines on, so gravity can't rob us of precious velocity, or at least not as much of it. Hot staging also helps to ensure the
Good
ship's
passing.
liquid propellants are at the bottom of the prop tanks, which is where we need them, which is where we need that propellant to be in order to quickly light the ship's engines.
So, long story short, why did they switch to hot staging? Hot staging means you don't need a separation system, guys. There are different ways to separate a rocket. You could have like a pneumatic push rod, like what Falcon 9 does. Falcon 9 has 4 push rods that actually just push the second stage away from the first stage. And since the first stage is way higher mass than the second stage, it'll just push it away. The hot staging ring right there, basically, it has the ship attachment points, right? Actually, it's great that they're showing this. And you have vents off the side, so when Starship goes to fire its engines, well, it's basically a flame diverter, like on a launch pad, but it's on top of the first stage. This basically means you don't need any separator. You don't need a pneumatic separator. You don't need what I was talking about, is like an ullage separator. You don't need ullage propellant. So the Saturn V basically had a bunch of compressed gas tanks when, like, gas, not like gasoline, gas like nitrogen or helium. So when you separated, the gas tanks basically depressurized and pushed the thing away, right? That's extra mass. That's extra stuff. And you want less rocket on your rocket and more fuel on your rocket. The reason why you want that is so you can put more payload on your rocket. The less rocket you have on your rocket means more payload on your rocket or more fuel so you can go further and move more into space. That's why SpaceX opted to switch to a hot staging. It's way simpler. All you need is an engine starter and then the latch separators, and that's it. Which the separators, the ship hold down system to the hot staging ring, you're gonna have. You need that already because you need something to hold it You need something to hold the vehicle together, right? So the hot staging saves you a bunch of mass. It's a little more complicated of a staging system, but hey, Titan's been doing it for a long time. Or Titan did it for a long time. Titan rockets used hot staging, as Kate said, from like 1957 to 2005. And even another one, like another counterpart there is like Soyuz. Soyuz has been using hot staging since 1966. And even before that, the Semyorka, which is what Soyuz is based off of, hot stages as well. Like it's not really hot staging because it doesn't have a third stage, but Vostok or Voskhod would be a better example. But hot staging is nothing new. Just, I don't think anybody's ever done it with a rocket this big. The only thing that would even come close to this is the Soviet N-1. And that thing didn't work. It did basically what happened on IFT-1. I'm going to be here through the whole thing, lads. Yeah, till end of mission. No matter what happens. What they were showing there is the pad deluge. Basically, last time when they went to launch this thing, it destroyed the pad and made a nice crater down here. They did get it fixed, and they put in that plate to be able to shoot water at the pad to make sure that the pad doesn't get destroyed. Also, when all of that fires, it can create a sound reverb off the ground. The water is designed to quench that sound reverb. It's called sound suppression. Rockets have sound suppression so they don't damage themselves on the way up. When you have a rocket with systems on board that can be damaged, tiles, you don't want the sound of the rocket reverberating off the ground. It can actually it can destroy the vehicle. So, just like it really messed up the bottom of the of Super Heavy during the IFT-1 mission. They dry fired that thing. I still can't believe that. And it didn't work. Go figure. So hopefully with this pad deluge system, we see a more intact vehicle leaving the pad.
Discovery, go at throttle up.
A little bit of column A, a little bit of column B, Zim.
Reusability is the key
Dude,
to making
look at this
routine
thing.
space travel a reality, and SpaceX has been working on this since its inception.
Yeah, with SpaceX's
Inception?
family of
Inception
Falcon
made
launch
sense.
vehicles, which are the first and only orbital class rockets capable of reflight, we started with, and Starship is going
Turbo.
to take this even further with a reusable first and second stage. Now, while most rockets are expended after their portion of the mission, SpaceX rockets land back on
It is
Earth
science
and are
fiction.
quickly returned to our hangars.
All right, so guys, Mutter, that's actually a good idea. What I'm gonna do, guys, I don't like running ads. I'll be honest with you, I really don't. Chat makes me run them during the day. I have it as a channel point redeem. But during launches, when we get inside of 15 minutes, I'm gonna run some ads right now, so nobody gets ads. If you're not subbed, first of all, I don't care. That's cool. If you're just here to watch, I don't care. You don't need to sub. It's no big deal. Falcon 1. I'm gonna run the ads now so people can watch the launch uninterrupted. Because I hate like clicking on something, right? Oh, geez, Starship is launching. Oh, here's a Taco Bell ad. No. That's very annoying. I don't like it. So I'm gonna run some ads right now. I don't really like to do it. I'm not gonna sit here and pretend like it doesn't make me money, but I don't like to do it. I don't like uninterrupted or interrupted viewing experiences. I want the launch to be uninterrupted for you guys. So we're gonna run them, and I'll see you on the other side, Ray.
Webcast, and it was so exciting to see that iterative
Discovery,
development
no
approach that we took
Hey,
finally paid off
Arcometron,
after
thank you for
so
the prime,
many
dude.
attempts of failing. Now that failure is expected to help improve future designs of our
Discovery,
vehicles
no
and
guy.
systems. So fast forward to present day.
Get ripped off.
We've
Where's my
landed
Taco Bell?
F9 boosters
Thank
over
you, Lithuanian. I appreciate it.
245 times since our first reflight of an orbital class booster 6 years ago.
Yeah, and it really comes down to our design philosophy. If you're not failing in some way,
Discovery, go and
then
throttle up.
there's room to learn and push the design to improve. And failure
will
doesn't just
soon,
mean
Levy.
blowing up a rocket. It might be not being as efficient as we want to be or producing slower than we want to. So that approach has been the basis of how we've made all of our major innovative advancements.
Woof.
Discovery, go at throttle up.
All right.
Decent.
Now, Falcon
With
9 has
15
certainly
and
come
go
a
with
long
5.
way,
Oh, you guys are
and
too
Starship
nice.
will too. But as a reminder, today is
Discovery,
a
go
test.
and throttle up.
We
Oh my
really hope
goodness.
to get to stage separation.
Oh my goodness, that's
but
a lot of
any
throttling
data
up.
received
Coder,
will help
passing,
us improve.
electron.
It's the second of many future flight tests of Starship
Discovery,
Whoa.
before
go and
it
throttle.
becomes fully operational.
And these flight tests teach us about the limits of our design. They help us improve our understanding of the vehicle, and ultimately will help us to make Starship more reliable and rapidly
Thanks,
reusable.
Charlie.
So again, whatever the outcome and however far we get today, we can promise excitement. So why are we doing all of this? Why do we need a rocket this big, and why does it need to be reusable so quickly?
Discovery,
And that
go and
answer
throttle up.
goes back to SpaceX's mission, which is to make life multiplanetary.
We aren't just building a new spacecraft. We're changing what it means to go to space. By building the most powerful rocket ever flown and a ship designed to carry people, cargo, habitats, satellites, and more, we're unlocking a future where our
Discovery,
dreams
go
of
and throttle up.
exploration will no
Guys are
longer exceed our grasp.
crazy with the
And
subs,
this
man. I
mission
appreciate
continues
it.
with
Thank
flights
you.
like today's integrated test.
And these are flights where we're going to fail fast, but
They might,
learn
Plavik,
even
yeah.
faster. Where each time we're going to try something new
Please.
while flying something that we've improved. And ultimately, that's going to build up a fleet to
Ew.
fly early and often as Starship rapidly evolves to become more capable and more reliable.
The first stop is our nearest neighbor, with a surface that hasn't seen visitors in more than 50 years.
Please.
Under Artemis with
10
NASA,
minutes.
Starship will return people
Here we
back
go.
to the moon. After those first expeditions, we'll be ready to fly more people along with everything that it takes to build a moon base. Think about that. Hardware that will
Think about
enable
it.
us to live on another world is sitting on a launch pad on Earth right now.
See? This is why we like
The
Kate.
moon is just the
We like
proving
Kate.
ground. When
Kate's
the time
pretty cool.
comes to make that leap to
We
Mars,
like Kate.
everything gets ratcheted up by orders of magnitude.
Think about it.
The logistics of supporting an entire city on Mars
Think about
are
it.
daunting, requiring millions of pounds of cargo flown from Earth spread out over thousands of launches. And we just broke
That's
our
cool,
own
Just
record
Space,
for
right
the
on.
number of launches in a single year, and we're going to break it again next year.
Now, in the years to come,
Steve
Starship
Winwood
is going to
reference
dwarf
from
those
you,
figures
Ian.
as
Good
we
for
bring
you.
it online and
for
truly
you.
make life
Yeah, Nab,
multiplanetary.
I'm with you.
But for now, anyway, as the clock counts down to today's flight test, why don't we get another status update from John?
We're just over 9 minutes from
I have it on
liftoff
X,
as the
Rebel,
countdown
or
clock
Twix,
clicks
or
to
Twitter.
0. The teams, good news is, teams aren't
Found a
working
Starbucks
any
in
significant
Dusseldorf to watch
issues
this.
on the
I've
launch
been
vehicle
wondering where
right
you've
now.
been, Zonic.
Propellant loading is continuing on both the Super Heavy and the
Dude.
ship stages. Most recently, we began
Indeed,
loading
Max.
LOX and methane fuel into the header tanks on the Starship.
NSF has a
On the
trailer
graphic
this
on
time,
the left side of
Talon.
the screen, you can see up in the nose of the second stage, what we call Starship, are those two header tanks for fuel and liquid oxygen. Now that loading started at T-minus 24 minutes and will continue until approximately T-minus 5.5 minutes. Now Starship's second stage main fuel and LOX tanks are loaded for flight. And the second stage propellant that we're loading on board is going through the quick disconnect. that
We
comes
are
out
so
on the
back
arm
right
that's
now,
located
someone.
At the base of the stage.
Weather,
from the
range,
tower.
and vehicle is go.
On the Super Heavy booster, propellant loading
We are so
will
back.
continue until
It's
T-minus
not
3
Jover.
minutes. We've also configured the pad for liftoff. A
Discovery,
little
go
earlier in
and
the
throttle up.
count, the
Snake.
hold downs. The booster hold
What's
downs
up,
were
dude?
commanded to unlatch. That
You
means
seeing
once the
this?
rocket
This
has
is
sufficient
great.
thrust to
What
overcome
a
its
freaking
weight,
monster.
it'll lift
I
off
can't
the
believe
pad.
this thing is
There's
sitting
no
there.
need to command the
That's
hold
so
downs
cool.
to release the rocket. As we mentioned earlier also, the ignition sequence has been slightly modified from the last flight for
Great.
more efficient liftoff.
Thanks, buddy.
As a reminder, we ignite the engines a few seconds before T0. We don't lift off exactly at T0. We lift off a few seconds later, a couple seconds.
I think it'll work,
Finally, the
Pravacar.
SpaceX team
Discovery,
continues
go
to
and throttle
check
up.
in with the Coast Guard to ensure there are no boats in the safety perimeter before proceeding with
Venting.
launch out over the Gulf of Mexico.
Venting for header tank fill.
Now,
That's what that
currently,
is.
we're coming up T-minus 7 minutes, 10 seconds.
I know, Snake. That's
The
cool,
test
right?
flight of Starship.
I wouldn't know,
Propellant
though.
loading
Or
is
would I?
continuing on both stages of Starship. We're waiting
I
now
wouldn't.
for the completion of
Seriously.
loading of the header tanks.
Mouse
in
off the
next few
screen. Sorry,
minutes.
guys. Twitter.
The first stage
Twix
is
video
also
does that,
beginning
man.
pressurization
It's
for
really
flight
annoying,
while
actually.
we are continuing to load
What is your
propellant into
prediction?
it.
I think it'll go.
And again, booster propellant load will finish at approximately T-minus 3 minutes.
I think
That
it'll work,
stage,
Just
both
Space.
first and second stages are fully loaded, and we'll have the 10 million pounds of liquid propellant on board the two stages of Starship.
So, for instance, just for a little bit of an example, all right? I know it's in pounds for the Euro Bros. I get it. Falcon 9 has 1 million pounds of propellant. This thing has 10 million pounds of propellant. Because how much propellant do you need? All of it.
If we need to hold,
Oh,
it would
look,
come
look.
at T-minus 40 seconds.
TVC
That's the
checkout.
point in the countdown, where we can pause to wait for final checkouts or
Did I see him move?
pressurization to complete. Or, as we're hearing right now, we're still working a few boats in the area that are headed south,
Whoa!
and a lot of cheering here in Hawthorne.
Whoa!
The boats are heading south, but we are still planning to hold at T-minus 40 seconds if necessary.
Boats!
Just amazing views of
Boat.
today's launch. There's nothing quite right like a launch at basically sunrise. Sunrise, I think, was just about 10 or 15 minutes ago out at Starbase.
Yeah, these views are just incredible. Couldn't ask for a more beautiful day to attempt a test flight here.
Bruh.
Again, these are live views
Look at
of
this.
Starship as it awaits its
Discovery,
second
go and throttle.
Hey,
integrated flight
Rams,
test.
thanks, man. And thank you, everybody that
Our
gifted
primary
subs. If I
objective
missed it,
today
I
is to
apologize.
get
I'm
through
kind of...
stage separation.
kinda
We really want
distracted
to
right
test
now.
out our attempt to perform hot staging, where we are going to
I know,
ignite
passing.
the engines
It
on
is
the
a
second
unit.
stage,
That is a unit.
while some of the engines on the first stage are still lit. So essentially, both stages will be making fire at the same time, and that will push
Wing
the
cam.
booster away from the ship. It'll separate
Stunt
the two
man.
stages. So that's the primary goal for
All right,
today.
we're
We
inside of
really
5
hope
minutes,
to
guys.
be
I'm
able to
shutting the
test that
alerter
out,
off.
But at the end of the
Okay.
day, all and any data
Thank you.
that we can
If you
collect
sub,
is
I
going
do
to be
appreciate it. I'm
incredibly
gonna shut that
helpful and
off
help
so we
inform
can-
future improvements
Hey,
and
C, what's up,
iterations
man?
of the vehicle.
Yeah, Kate. There are other objectives for today too.
Okay,
Assuming
this is
we
a ground
get
gas
farther
closeout.
Then stage separation. There's
That fat vape that's coming off the tower, they're evacuating all the propellants out of the fuel lines that go to starships, that go to the Starship, the second stage right here. That's what that is. They're basically pumping nitrogen up the lines here to get the methane and the liquid oxygen, there's the two, out. You don't want propellants inside of the pad. You're not trying to launch the launch pad into space. You're trying to put the vehicle into space. So they vent all the propellants overboard. On the tower, not on the vehicle. The vehicle does have these vent valves right there. Those vent valves are to make sure that you maintain the right pressure. You don't want to have your delta P change too much on the rockets. Delta P. No, change in pressure. You want your pressures to stay uniform inside of the fuel tanks. The problem is that your propellants are boiling because they're cryogenic propellants. The only way to store methane, which is generally found as a gas, and oxygen, which is obviously found as a gas down here, right? The only way to do that is to freeze the dang thing to get it to turn into liquid. Interestingly enough, freezing it turns it into liquid, and then if you freeze it even more, it turns to a solid. But in this particular case, the propellants are boiling because they're cryogenic, right? And when they boil, you have to keep constantly venting. You have to constantly vent. It's kind of sus, right? But you have to constantly vent to maintain your pressures. If you just sealed the tank and filled it up with propellants, it'll overpressurize and, well, balloon popping. We don't want that. So you do see periodic vents coming from the vehicle. But this one right here, the ground gas closeout, is a good indication of being ready for flight. That means they're moving the fuel out of the lines that go into Starship.
Exactly at T0, that 40-second hold is super helpful. If we need to, for example,
Can't tell, Oculus, I'm not sure.
you know, we need more time to pressurize the COPVs for flight levels.
Oh, man.
You know, perhaps
if
fuel.
the engineers just need to look at some of the data, see how engines are performing, or the avionics.
Exactly, those checkouts. You know, being able to have the
Hey, Ant.
opportunity to top off the fuel or LOX if it's not fully loaded, and you know, we might want to just take a few more minutes for that. So that T-minus 40-second hold can be really helpful, but you know, we don't have that option on Falcon, so it's a little bit different here.
Just
154.
inside T-minus 2 minutes and counting. The good news right now we're hearing
Farron.
it doesn't look like we're going
It's
to
a
need to
big
hold
mother.
a T-minus 40 second as the boats are clearing out of the way. Next event coming up, TVC wiggles as we move the center engines on
Thrust
the first
vector
stage.
control checkout. They're basically making sure the steering wheel works. There's no steering wheel.
You
Oh,
can
there they
see
go.
maybe
Look at the
just
engines.
a little bit there. 90 seconds. Wiggles are underway as we're checking out the first stage.
Okay, inside of 90 seconds here.
TVC checks are complete.
Oh my goodness.
Next major event we're going to hear, hopefully, is
on.
the flight director go for launch
Come
at
on.
T-minus 30
Come on.
seconds.
Right, it was real quick, huh?
As we're coming up on T-minus 1 minute, when we get to
60
T-minus
seconds.
40 seconds, we'll just listen in. Last time, as you recall, we did hold at 40 seconds, but it took a few seconds for the clock to recover, so we're going to watch that. And as we press to T0, we're going to watch and listen the second test flight of Starship.
45. The cheering sounds like the clock is running. Countdown resumed, T-minus 35. Let's fly.
T-minus 30 seconds.
Holy crap.
Back to rapid recycle.
Hold. Hold. They called I heard recycle on the countdown net.
Back at Hawthorne, we're T-minus 40 seconds in holding. We had a rapid recycle. We've not heard anything over the countdown net as the team works both first and second stages.
We've got about
We're gonna
20
monitor
minutes.
the nets here for a minute.
20 minutes of leeway, guys, so we'll see what happens. Ooh. Ooh. Nervous?
Got a little bit of an update. We're continuing to hold at T-minus 40 seconds. This is the normal hold point for Starship, as we talked earlier. Sounds like we're working just late pressurization on, I believe, the second stage. Team is working it. All the other systems are on hold right now at 40 seconds. We can hold here for about 15 minutes or so before we would run out of window for this morning.
Come on, baby.
So right now they're working on filling pressure vessels. And ideally we'll be able to solve this and come back and release the clock at T-minus 40 seconds. We're going to continue to listen and monitor for another few minutes.
So the computer's on board Starship, the auto sequencer. It saw something. It saw bad pressurization. Remember, I was talking about delta P a little bit earlier. You have to make sure the pressure's a constant. If pressure in a tank is just
it's worth mentioning here
a little bit low,
that don't go away.
It could break
We're holding
something.
at T-minus 40 seconds, but once the teams have resolved and see the data that they want to see, the clock can restart straight away, and it'll start ticking down from T-minus
Orbital
40 again,
mechanics, zombie.
all towards liftoff.
Yeah, exactly. Now, while we do have the ability to hold for up to 30 minutes, we only have a 20-minute launch window, so don't go away. Don't change the channel. And just like Shiva said, we can restart that clock, and there it is.
And there it goes.
here we go.
Clock
35.
is rolling. T-minus 30 seconds.
Oh, man. 25. Okay. 20 seconds to the launch of IFT-2.
T-minus 15. 10, 9, 8, 7, 6.
Here we go.
5, 4, 3.
Sound suppressor is on. Ignition.
We have liftoff.
Liftoff. Fly, baby, fly! Yeah!
Vehicle pitching downrange.
Booster chambers pressure nominal.
We are T-plus 40 seconds into the flight of Starship. 33 Raptor engines powering the first stage.
Power and telemetry nominal.
We've
Good
heard
call for power and telemetry, man. No engines out.
Heading downrange over the Gulf of Mexico.
Going to max Q. I'm going to move over the other side.
And that call out tells us Starship is through the period of greatest stress on the way to space.
Through maximum dynamic pressure. Here we go. That's
Now,
the highest
major
load
event
induced on the
is hot
vehicle.
staging in just over 90 seconds from now. To get ready, the booster will shut down all but 3 of the Raptor engines. Clamps holding the 2 stages together will release, and the Starship's second stage will ignite its engines. Starship will then separate from the Super Heavy booster and head to space. And at the same time, the 3 engines that are still firing on Super Heavy will flip the booster around. 10 more engines will ignite for the boost back burn, putting the first stage on path for a splashdown in the Gulf of Mexico.
Come on. What a shot. Coming up to engine cutoff here. All the engines are going to shut down except the center 3 on Super Heavy.
Engine power continues to look nominal on 33 Raptor engines.
How?
We're about to
That's
shut down
so
the first stage
impressive,
and
dude.
perform staging. Let's watch and listen.
Come on.
And acquisition of signal Houston and New Orleans.
AOS through another ground station here.
Booster engine cut off.
There's hot staging.
Stage separation.
Oh my goodness! Holy shnikes! Look at that! Oh my goodness! That was impressive! Oh my goodness, they lost some motors, it looks like.
The first ever successful hot stage for SpaceX's
Holy
Starship.
Incredible views of our Super Heavy booster.
Oh!
As you can see, the Super Heavy booster has just experienced a rapid unscheduled disassembly. However, our ship is still underway.
It didn't like that.
Avionics, power and telemetry nominal.
And we just heard there, ship avionics.
But Starship
power
is
to
going,
nominal.
man. It made it away
Engines
from
are
it.
lit, as you can see
Oh my
visually
goodness.
there at the bottom right-hand side of your screen. Now, we did know that the
flight termination system worked.
hot staging was going to be incredibly dynamic. We knew that there was a chance that the booster would not survive, but we're going to take that data and figure out how we can make the booster better
That's
for the next
impressive,
hot
dude.
stage.
Yeah, that hot staging put a lot of load on the top of the booster.
Yeah.
And of course, it flipped around there, a lot of dynamic stuff happening. But ship is still going strong.
And it's doing great. Right now, the ship, the second stage,
Oh my
is
goodness.
on its way. Like we said, you
Oh
can
my
see all
goodness.
6 of its engines are ignited. The next major milestone for the ship will be the shutdown of those engines, or SECO, second engine cutoff, which if you
Okay.
follow our Falcon 9 launches,
That was
familiar
awesome.
terminology there.
But we're not done.
So far,
That
today
number over
has
there
been
needs to be like
incredibly
27,000,
successful,
guys.
even with the RUD of the Super Heavy booster. This is amazing.
Yeah.
Primary objective
said
of the
it,
booster
Kate.
today, to get to hot staging, to get ship on its way to orbit. It did that admirably.
Yeah, we definitely asked.
Starship trajectory nominal.
Oh my dude,
All
it's
right,
actually
that
working.
trajectory
Oh my
for ship
goodness.
is
Acquisition of
nominal.
signal Cape Canaveral.
Once again,
AOS
Starship
through the
second
Cape,
stage
baby.
is firing those engines, and as you just heard,
It's above the
everything's
Kármán
looking
line. Good call.
Now for the ship,
Starship
we,
is in
wanted
space.
it to survive hot staging, which, as you can see there by that little
It's
dot
not to
on your
orbit yet,
screen,
but
it
in
did.
space is.
We also
It's there.
want to basically demonstrate that the successful startup of that of those engines, demonstrating controlled ascent, which is what it's doing right now, and eventually orbital insertion. We are hoping to basically send this around the Earth,
gotta be kidding
and
me.
if it makes it this far, splash down in the Pacific Ocean,
Right, Brahms?
a couple hundred miles north of Hawaii. Now, if we get that far, like all of that sounds great. Secondary objectives for
There
ship,
should be cameras
again,
on board,
continuing
Funky.
to
I'm not sure if we got a
gather
picture, though.
engine data and about its health, performance.
Nominal ship chamber pressures.
Great news there. That tells us that
Good
the
report
chamber
from Flight
pressures
Dynamics.
inside of the Starship, again, that's that small dot on your screen. Basically the propellant pressures in the ship are looking good.
Yeah, the bottom right corner of your screen, you can see essentially a user interface showing
Yeah,
us which engines
way
are
past
lit.
it,
So the
drummer,
3
way past
center
it.
sea-level Raptor engines on ship are
We'll
gimbal
find out, buddy.
engines. The 3 outer engines in the triangle, the larger
Nice
ones,
comment.
are Raptor vacuum engines. All of them continuing to fire nominally, so they're at the pressures that we expect to try to get into our target trajectory today.
Yeah.
And we're not targeting orbit today. We're targeting almost orbit today. That's very intentional as part of the mission design. The goal is to get to a thrust profile similar to what we would need for orbit.
It's okay,
but
Howard.
also
And
to
expect
get
the
to
loss
the
of
energy
signal,
levels
Houston.
that the ship would need to dissipate for re-entry. And so we're actually going in a suborbital trajectory today, but that trajectory will get us to the energy levels that we need at re-entry, where we can really stress that heat shield
Plume is
and
being
get valuable
illuminated
data
by
on
the sun.
re-entry. And those calls that we are still on a nominal
Dude.
trajectory here and seeing nominal pressures means that we have a really good shot of hitting our target orbit.
Yeah.
Past
Now,
20,000,
if the
7 minutes,
booster
30
had
seconds into the flight,
survived,
148
we would
kilometers
be,
on Starship.
around the time where it would be getting ready to land, performing its
Everything.
re-entry, but it unfortunately did not survive. That being said, that's okay. It
not sure what that
survived
outgassing was.
several
Terminal
seconds after
Starship's in
hot
terminal
staging,
guidance.
So we're going to take that data
We're close.
and improve the hot staging sequence and probably improve the hardware itself for the next flight.
24,000. So 27,000 is orbit. That looked like a stage shut. That did not look like a stage shutdown. That did not look like a stage shutdown. It may have been, but it got awfully quiet.
They're standing by for a call out here. Coming up on the projected time that ship would shut down its engines.
There's no telemetry there. Come on. Come on. Come on.
As you can tell by the excitement from the crowd here at Mission Control Center in Hawthorne, there's a great view of our Star Command Center. That's our control center at Starbase Texas. The crowd here, Mission Control Center behind us in Hawthorne. Everyone is super exciting. What a successful day this has been so far.
Yeah, awaiting acquisition of signal. It looked like the engine shut down, and then there was another pop after that, and then the telemetry went out. So that could be a couple of different things. They could have just gone what's called over the hill.
Up to this point,
So you have a loss of signal for a
successful
second?
Milestones through hot
Or
staging,
it
which is the
exploded.
big objective today.
Could be one or the other.
So we are going to head into the coast phase.
There's Elon.
Planned
Elon and
for
his
the
brother
next
right there. That's
about
Kimball next
hour
to
and
him.
5 minutes. We'll be
And
returning
that's-
around the T
I
plus
think
1
that's
hour and
Kiko
15
Donchip
minute
right
mark.
there. He's a
And
SpaceX
that's
flight controller.
While we're waiting for Starship to continue on to its next step for re-entry, we're not totally sure what video we're going to get.
Hey.
And that video comes normally by overflying ground stations, but we don't have a ton along our flight path. So fingers crossed that we will get some via Starlink on this mission since we're testing that out. And also give us a moment. We are hearing some chatter on the net, so we're going to try to parse that for you.
Just parse it for me, bud. Come on. Hey, there's Chris G. There's Chris G. Over on the left. Hey, my guy. Hey, sweet. That's cool. I've worked with that guy before. Chris G was a commentator and editor for NASA spaceflight for a long time until Elon poached him. Elon's like, I want you. He's like, all right. The guy in the hat, the guy with the hat with the multicolored vest on, that's Kimball Musk. That's Elon's brother.
Our next worker back here in Hawthorne at our webcast desk. We have lost the data from the second stage. We had heard a call out that we were in terminal guidance, which means we were getting near the end of the approximately 6-minute burn of Starship. But we haven't gotten any more data since then, so we think we may have lost the second stage. So we would not be into coast phase. We wouldn't be able to come back in an hour or so and possibly get ready for reentry. However, what we do know right now is we had an on-time launch at 7 o'clock. We got through the boats. First stage looked beautiful with 33 Raptor engines firing. We got the hot staging, you know, the thing that we really wanted to see and impressed. We saw the separation. We saw the flip maneuver. We saw the light up of the 6 Raptor engines on Starship, and it headed away. Everything really looked good. But what we do believe right now is that the automated flight termination system on second stage appears to have triggered very late in the burn as we were headed downrange out over the Gulf of Mexico. But the real topping on the cake today, that successful liftoff, Kate, Shiva, the hot staging is just beautiful.
So
exactly
cool.
what we were looking for.
Yeah, ultimately, honestly, such an incredibly successful day. Even though we did have a RUD or a rapid unscheduled disassembly of both the Super Heavy booster and the ship, that's great. We got so much data, and that will all help us to improve for our next flight.
Of course, and that's why we flight test, and you can bet that there's going to be more to come. So we really do want to thank you all for joining us. Of course, we want to thank the people of Cameron County. We want to thank all the federal agencies that have supported us for our test. And of course, a huge congratulations to the entire SpaceX team on getting through this flight test today. And I think with that, we're going to sign off from here in Hawthorne.
Thanks so much for tuning in, and we'll see you next time.
It popped. Yeah, it popped. How about that, huh? How about that? Apologies for the terrible commentary. Sometimes it's just, okay. Here, let's go over to our buddies at NSF here for a replay. Let's see what they had on their end. Let me just fast forward it up here.
We see the Fire X, the Deluge, and then it's go. Oh,
right. And we'll
let's see. No, guys, look, if the flight termination system went on ship 25, it was going fast enough where most of the pieces would just disintegrate during reentry. 24,000 kilometers is almost orbital velocity. It's very close. No, most of that would just burn up. The only way it's going to get through reentry is in one piece. And if it's multiple pieces, it's not getting through reentry. All right, let's see.
No fire X right now we are past now. Okay, so Alex, what do we got here? Yes.
I want to hear how hype Adrian and everybody else got. Give me 1 second.
Time to be able to. The left in. All right, enjoy everybody.
Here we go. No problem, Havocs. We're gonna watch a replay here. Dude. Dude, that first stage looked money. I can't believe, dude, look at that. This sound's just blowing out the mics. There's no way you can record this. Unless, like, at the range that those microphones are at, there's no way you can get it to not do that. Yeah, it is. Wow. You've got to be kidding me. So, I'm trying to decide. Hey, Bill, thanks for the subs, dude. I'll turn the alerter back on. Thank you very much. And then everybody that did it sub when the alerter was off, I appreciate it. I can't tell if that's ice coming off the booster or if it's tiles coming off. Every once in a while, you're seeing some plume interaction here with something that's coming off. I think it's probably ice, but dude, unfreaking believable. It got close, Memphis. I think the flight termination system popped it.
I believe at this point it's safe to talk again, as we see.
Hey, Farron, thank you very much. Look at
with
that.
all 33 Raptor engines
Yeah.
working here.
This is
already
mind-blowing.
past. Yeah, already past max Q, approaching.
I can't believe it made it that far, dude. The hot staging was magical. That's unbelievable. Never seen anything like that.
Here, they're about 30 seconds away from the hot staging moment. This is where we will see this event we all have been waiting for.
Oh my goodness.
Watch for it. I'm so excited to see this.
Yeah.
That's right, Hazanku, yeah.
It just shows you how much effort they put in between these two flights to get to this point. And hot staging's
Absolutely.
next.
Oh, wow.
Great job by our NSF crew getting these images to us also.
I believe that's
Right.
hot staging.
I think so.
That is. Oh my god!
What a
Next
freaking
up, let's
treat.
see if we can see the boost back. That looks like, yep,
Oh,
looks
God.
like it's
It's
boost back
working.
working. Look at that.
It works.
Yeah, it's about to not work. The NASA spaceflight shot showed it. The booster started going off the trajectory. You see it like kind of turn to the right. Yeah, right there, and then
It looks like it's working.
then it popped.
And with this, ship 25 is on its way to Hawaii.
Oh my god.
Oh, wow.
Ship 25 is already past the McDowell line. It's already 90 kilometers up.
The McDowell line.
Oh my god.
Nice.
This is unbelievable.
That's crazy.
I mean, this couldn't be more picture perfect right now. And, you know, I think...
That's absolutely insane. Here, let's guys, what I'm gonna do, I'm gonna flip us back over to the SpaceX playback. Give me one moment here. One moment. All right, here. This is a replay. This is a replay of what just happened here.
T-minus 15. 10, 9, 8, 7, 6, 5, 4.
I want to see this again, dude.
2, 1.
Dude, hold up. Hold up 1 second. 1 second, dude. Look. Watch the shock wave that pops out of this thing when they start the engines. You can see the pressure, the overpressure event. It'll just zap out. Watch. You know what I mean?
8, 7.
Down the bottom. It's a freaking shock wave that comes out of the bottom of the booster.
3, 2, 1.
Oh, that's so good, man. Yo, Bloodfam, what's up, brother? Holy crap. That's impressive, dude. What a freaking treat. What a treat. That's unreal.
Booster chambers pressure nominal.
Unfreaking believable. Dude. Yeah, I think that's just ice coming off, but it very well may be tiles. There's some, looks like there's some white patches on ship 25 up there. I think those might be tiles coming off.
33 Raptor engines powering the
Booster
first
engine
stage.
up, power and telemetry nominal.
We heard power and telemetry nominal.
How tall is it? It's about 350 feet. Base face.
Discovery, go at throttle up.
Laser Man, what's up, dude? So this is a replay from just a second ago here. Look at that, dude. That's something out of a sci-fi flick. Unbelievable.
And that call out tells us Starship is through the period
No problem,
of greatest
Raven.
stress on the way to space. Now the next major event is hot staging in just over
Vic,
90 seconds from now.
Hot staging was
To
the
get
real
ready,
key
the
with
booster
this
will
test.
shut down
They got
all but
past hot
3
staging.
of the Raptor engines.
The reason
Clamps hold
now,
up.
obviously, you don't want the whole thing to just explode, but that is what happened. But also, SpaceX has another one of these babies teed up and ready to go. Like, I'm serious. The next flight is going to happen a lot quicker than the difference between Flight 1 and Flight 2. They're cleared through all the environmental and flight licensing, so they should be able to launch again sooner rather than later. But the real key to this test was the hot staging. That's what Elon said on the other day on Twitter and stuff. And just from what I know about rockets, the staging, a new staging mechanism is staging is one of the most complicated parts of the entire mission by a long shot. And it did work, but I'm pretty dang confident that they had a LOX feed problem or a methane feed problem because the methane tank got destroyed by Starship's engines firing. Yeah, Reaper, it's really impressive. Look at that. 33 up and burning. That is an immense feat by itself. They sequenced and ignited 33 engines in 2 seconds. It's not just hitting the on button. That is an insane amount of physics going on there. There's the hot staging. And it looks like they went to relight some of those engines and they didn't get a full relight, I think. And so what happens here is, because if you look over there on the left, some of the engines aren't igniting and it's pushing the booster off of its planned trajectory. The computers on board are designed to detect if the thing moves away from its planned trajectory. If it strays too far out of its nominal trajectory, this happens. Wait for it. Look really close. You might not be able to see it. That happens. Yeah. If it strays too far out of its trajectory, the computers say no and they blow the thing up. How does it explode? It has gigantic bricks of C4 attached to the side. Yeah, they're about yay big. Yeah, I don't know if you could tell that it popped, but it popped like a freaking balloon. It looks like they didn't get a good relight. So the reason why it most likely is, Shiva said that they had a methane tank leak. It's from Starship's engines shooting rocket exhaust on the top of the methane tank. It compressed something. So that is something to learn, but the hot staging did work. That's really, really important. That was the critical step in the flight. Honestly, this part was the most important. If they got it to that point, they got to staging, they tested the staging mechanism, it worked pretty good. That's unbelievable. So the reason, a reason maybe why they didn't get a good relight is because your feed right here. If your methane tank isn't at the right pressure, I was talking about pressures before. If it's not at the right pressure, it's not gonna you're not gonna get your right inlet feed to the engines, and the engines will end up sucking nothing, which is probably what happened here. But also, the physics of turning the booster over like that and relighting the engines while the booster is turning, because when it's turning, it's sloshing the propellants around. Even though it's under acceleration, the propellants are still floating around. And don't get me wrong, there's baffles in the tank, but they clearly didn't get a good relight on some of these engines. And some of them did pop off there. Yeah. It's interesting to note that the engines that didn't work were all on the same side. So that could have been because when they flipped the booster, all the propellants went to one side of the feed lines. It's possible. But because they don't have, they have off nominal propulsion right here, because it's some of the rocket engines are working, it's shooting the booster off trajectory and it blows up. So it shut down all the engines, and then it figured out, it figured out that it was way off target and it just exploded. That thing is what, 21 stories tall? Yeah, pretty much. The booster is about 220 feet, or about 70 meters. It is a big mother. That's a 9-meter stage. So it's 9-meter core diameter, 33 feet for the America units. It's 33 feet wide, 220 feet tall. So 9 by 70 for the metric folks. It's not small. The fact that that thing's just whizzing around, no big deal, is pretty damn impressive. Where can I watch this? Right here? Hey, yeah, Max, I think you said it best. I think the FTS works. I think it worked that time. I think it worked. I think it worked that time. Also, I noticed that we didn't get an onboard shot during the cast. Interestingly enough. Yeah, Ian, for real, dude. I wonder if the flight termination system was too aggressive. It's possible. It is entirely possible. Thank you, Twitter video. Very cool. It's possible that the parameters for flight termination system were far too conservative. Well, no, far too liberal on the parameters. So what does that mean? Like, I said those words and people went, what? No, so like the parameters on which constitutes the termination system to explode may have been set too tight. So, like, say a temperature in a tank exceeds like minus 100 C. So if one of the tank temperatures goes to 99, it'll register it as off nominal and blow it up. Your parameters could be too conservative there. Yeah, no, conservative parameters are something that you see with test flights, because if the thing you really want to run a tight ship, because if it does something wrong, you don't want it to fly into somebody's house, because you're not exactly sure what the booster's going to do. So
that being said, that's okay. It survived.
I saw something happen right. So this right here, that's the sun illuminating the plume. So as Starship gets higher up in the sky, right? You because the sun's just coming up, you get more illumination on the plume. So that right there is right. That's correct. But I did see something here. And I didn't say anything because I wasn't exactly sure, because it may have been the reaction control systems, but something pops right there. Did you see that? That is kind of in line with the reaction control system pulsing. So what's RCS? RCS are tiny little thrusters that spacecraft, they're like small little rocket engines that spacecraft use to stay on the same trajectory. Once again, it's all about following its imaginary trajectory, following the nominal trajectory. The nominal trajectory has like a track. Think of it like a tube, like if you're playing Trackmania, it's it's a tube, and you don't stray too far in and out of that tube. If you go out of its track, it'll blow up. But if those parameters are set too conservative, it could have blown up. It could have blown up when it was just fine. But usually you have really, really tight constraints for a test flight, because you don't want this thing, like I said, you don't want it veering off course and crashing into someone's house. That's not good. So something did happen there. It does look like an RCS outgas, but I'm not 100% sure. And I saw right at engine cutoff, we saw a big pop. And then we immediately lost telemetry on the vehicle. So if you watch, that SpaceX does show live telemetry. That is what the vehicle's doing. That's not like a animation of what's going on. This is actually a very primitive flight interface. So you can still see it right there. If you're watching on mobile, this is going to be really difficult. It looks like a piece of booster fell down in the foreground there. So right there. Yeah, that's an explosion. That flight termination system triggered. Abso-freaking-lutely. So something happened at main engine cutoff here. Let's watch it again real quick. So, or not main engine, Starship engine cutoff. I guess that would be main engine cutoff, right? So when rocket motors shut down, they usually spray helium through the motors. They purge out the engines with helium because you can get residual ignition. Think about it like if you have a garden hose and a sprinkler, and you turn on the garden hose, it takes a second for the water to get to the sprinkler, right? And then if you shut it off, all the water stays in the line. You don't want that with a rocket engine, because the propellants, it's not necessarily the methane, but it's the liquid oxygen. I have some bad news for you. Liquid oxygen oxidizes things really badly. It makes stuff rust. So it's important to get it out of the rocket engines quickly. So they shoot gaseous helium into the Raptor engines, and most rockets do this. Any rocket that's going to be restartable, right? They shoot helium into the engines to get all that gaseous methane and gaseous oxygen out. So you should see a pulse when you get an engine cutoff on vehicles. That does happen. It just doesn't happen like what I think is going to happen here. So that right there, that is a helium pulse for sure. I'm pretty sure. How am I pretty sure? Well, the dead giveaway here is, well, it looks like one. But watch the telemetry here for a second. 24,123 at 148. Watch. See? The telemetry changed. See the numbers? The numbers changed. So that indicates that they still got a signal with the booster because 24,123 went to 24,124. 24, that extra kilometer an hour could be some of that residual pulsing that I'm talking about. And then right after that, you had an explosion. And the number doesn't change after that. So the flight termination system popped at main engine cutoff. Right after they shut the engines down. Now, what could that be? That residual thrust that I'm talking about, you did get a number increase here. The residual thrust could have damaged something, and the computers could have recognized that it damaged a motor. Sometimes, like I said, you're gonna get a little bit of residual thrust. Even if you purge the engine out with helium, you're still flowing the rest of the gaseous methane and gaseous oxygen out the rocket nozzle. And sometimes they combine and have contact with the hot rocket nozzle, which is hot and can auto-combust propellants. That can blow up engines on shutdown. It's definitely possible. Now, once again, you see this right here. There's cutoff indicated, and you see there's some residual thrust and then an explosion. So I'm pretty sure they had some trouble shutting down some of those engines. If I had to guess, this is a huge guess. Please don't take what I say as gospel. It probably was the vacuum engines, if I had to guess. But it could have easily been the three in the center. What variable is not checked before helium pulsed? Is that is checked right after? What do you mean? It could be too much residual killer. Sometimes that can make stuff pop. Residual propellants during engine shutdown is actually a big problem. That's really hard to do. SpaceX makes it look really easy with Falcon 9. But this does happen. Actually, residual thrust got a Falcon 1 flight, if I'm remembering right. I think it's Falcon 1 Flight 3. It popped that flight because the first stage shut down, and then residual thrust pushed it right back into the second stage and blew it up. I think that velocity is still a bit low for Hawaii. You'd need to get near 20,000. Now, once again, human, you'd need to get near 27,000. That number right there could be the flight termination system could have shut the engines down early if it saw something it didn't like. And if I had to guess, it looks like that first pulse may have had something to do with it. See, because right there, see that? I'm not sure what that is, but SpaceX's telemetry doesn't necessarily register that as an engine cutoff. So they still have 6 good engines, but you know, the more and more I think about it, the more and more I think something may have broken here. But once again, highly speculative. What I can tell you is that it did explode. It definitely popped. I knew it right away. There's a difference between the shutdown purge and an explosion, right? Seco's not fast enough. If they didn't get the mixtures right on the engines, Valksy, it could have blown it up after engine cutoff. Yeah, that's possible. Getting your burn rates and your propellant feed rates is really difficult to do. It's something that's really hard to get right. Because, okay, think about it like this. You have a car, right? And you want to drive your car 160 kilometers, so about 100 miles, right? You want to drive it 160 kilometers. And you have to fill that car up with gas so it runs out of fuel exactly at 160 kilometers or 100 miles, like to a T. That's really difficult. That's really hard to get that right. You know, there are dynamic flight conditions. It's called aerodynamics for a reason. Stuff changes. So getting propellant feeds, especially with a newer engine like Raptor, you know, in an integrated test on Starship that's going 24,000 kilometers an hour, right? It could screw things up. Getting prop feed like that is that's hard to do, especially if there was some damage during staging, because the hot staging clearly wrecked the booster. It clearly wrecked the booster. The LOX level started going down faster after the puff. All right, here I'm gonna move to the other side and we'll watch it. Let me see. So keep in mind. All right, so the people that are looking over here, you're looking at the amount of liquid oxygen, the amount of methane that they have. Keep in mind your oxidizer to fuel ratio, right, might be higher. So these tanks, hey, Diagonalizer, thanks, man. Thanks for the 10. I appreciate it. Thank you for all the support, guys. You're the best. And Cosmic with a 51-monther. Thank you very much. Do you think there will be debris entering over the Pacific? No, this is going to splash down in the Gulf of Mexico, or at least into the Atlantic Ocean. So just because there's more methane here than there is liquid oxygen doesn't necessarily mean that there's a fuel feeding problem. I mean, it's rocket science, dude. It's difficult. You have a, I say air to fuel ratio. You have a stoichiometric ratio with rocket engines, but you might carry more methane because if you know a little bit about cars, if you run fuel rich, you make more power, but you also run cooler because the fuel can absorb, the unburnt fuel in the combustion cycle can actually absorb some of the heat, right, that the rocket engine makes. So you might carry a little bit more methane than you do oxygen. So just because one is higher than the other doesn't necessarily mean that, something is wrong with propellant feeds. Let me see. Somebody was saying that the locks went down. I don't see anything. It looked fine. It looks okay to me. It's really hard to tell. I'd need a number value there. But once again, if I had a number value there, I'd be able to tell you what's wrong. But also, I'm not a flight controller for SpaceX, so yeah. But dude, what a wild freaking mission! Can you believe it? Dude, I gotta see the hot staging again. That was damn impressive. After the first puff, maybe Dennis, it didn't look. It looked okay to me, but I'd have to look at it again. The booster was rotating quite fast. Igniting the other engines on one side only might be just to assist in that flip maneuver. I'm pretty sure they lost the motors, human. Shiva said that they had some problems with the methane feed. He said that. There was some damage to the booster. And Shiva does have the information in front of him. This is what I like about SpaceX. The people that are casting, so John, Kate, and Shiva, they aren't just some people that look cool, all right? They aren't there for the good looks, even though they could be, right? No, they're actual engineers at SpaceX. Like John Innsbrucker, he's a famous, like a really, really, really well-respected engineer. The gentleman that was on the left, the gentleman that talks like this. John Innsbrucker worked on the Evolved Expendable Launch Vehicle program in the Air Force. He's like a 30-year Air Force vet that worked on Titan, Delta IV, Atlas, Delta II. Like he's worked on everything. And then, when he retired, he joined SpaceX and now he works on this stuff. Right? He is amazingly smart. I learned a lot from that dude because his technical explanations are fantastic. So, like, those three right there, they're all engineers. So Shiva knows how to read the data, and so does Kate. John, obviously, look, John has a notebook because he's old school. That's hilarious to me. A guy has a notebook. I never noticed that. But like I said, they're not just commentators. Those are engineers that work at SpaceX. Hey, T-Dave. He's got a paper binder. I never noticed that. That makes me laugh. That's pretty funny, dude.
Discovery, go at throttle up.
I love it, man. I write everything down, dude. I love it. He's freaking old school. He's unhackable.
Discovery, go at throttle up.
So Shiva did say that that there was a loss of methane in the booster tank. So he said there was some damage from it. So human, I'm inclined to say that I long story short, I believe what he's saying.
4, 3, 2.
Discovery, go
Like
at throttle
15
up.
seconds. Hey, yeah, T-Dave, thanks for all those subs, man. You guys are too good to me. And Cosmic Impulse, 51-monther before that. Dude, you've got to be freaking kidding me. Is that something else or what? 350 feet tall, a little over 100 meters. 9 meter wide, that's 33 feet wide. Unfreaking believable. That looks like something out of a freaking sci-fi film, dude. That's so freaking cool. Dude, look! Bro! Oh, good. Look at this thing. Dude. And I'm pretty sure those are tiles coming off there. Those little pulses that you see coming from the top. Yeah, I'm pretty sure those are tiles falling off. Can you believe that? A little bit of a step up. That's a little bit of a step up from the first flight, man. How do you think the pad health is? Seems to be okay, Rob. Yeah, Hokey, it's definitely tiles. Here, we'll flip. Oh, we'll check NASA spaceflight here in a second. They probably have some good views of the pad.
Starship will then separate.
You think so, Mikey? Let me take a look, dude.
And at the same time, the three engines that are still firing on Super Heavy will flip the booster around.
I'm speechless. I don't know what to say. That's unreal. 15 million pounds of thrust. That's like, okay, so for the metric, that's 70 meganewtons of thrust. Because how much thrust do you want? All of it. I want all the thrusts. Holy crap, dude. That's impressive. How much thrust do you want? Yes.
Engine power continues.
Maybe, yeah.
On 33 Raptor engines. We're about to shut
Can you
down
believe
the first
that?
engine performance.
How much you want? I don't know. How much you got? Impressive that it can stand it. Yeah. Brando, right? That's what I mean, man. 15 million pounds of force pushing up on the booster. Oof. Oh, it looks like it veered a little bit. So, here, check this out. Before the engines light, right? So you see all this stuff, right? Before the engines light, they got to prime the motors, right? You got to prime them. So what happens here, what you're seeing there is actually some gaseous methane and gaseous oxygen coming out of the hot staging ring. On Falcon 9, there are dedicated vent tubes that come out the side, but since it's a hot staging ring, they just flow out of the hot stage, out the sides of the hot stage ring. That right there tells me that once again they're priming the engines for what's about to happen. That's normal. See, there's your helium purge. It's much easier to see on this stage. It looks like one of the engines didn't purge, but then again, the plume is, well, trisymmetrical, so maybe not. Yeah, it's symmetrical. That's fine.
Stage separation.
Dude, what the frick, man? That's unreal. Something happened right there. Dude, that's a 22-story building flying around. 22, that's 22 stories. So if you live in a city, go find a 22-story building. That's how tall that thing is. It's just flipping around like it's no big deal. Yeah, exactly, Torlab. What the frick? You gotta be kidding me. Somebody catch it! You don't want to catch this one, Meow. Thank you for the bits, Jackery. One hop. Second stage engine cutoff was supposed to happen at T+833 run at 8:08. Yeah, they were trying for 27 and they didn't get it. Something went wrong with Starship.
Discovery, go at throttle up.
Is this live? No. No, this is a replay. Oof. Okay. That exploded. That exploded a lot. Dougie. Thank you, Fresh. NSF got the shot there. Let's see. Let's see what the explosion.
This is my
That's
shot.
your footage.
This is
Yeah.
the booster. This is the booster exploding. Whoa.
Really?
Here we go.
Oh!
It's gone.
Yeah. That's got a lot of... That's a lot of boom.
That's one of the most beautiful things I think I've ever had a camera pointed at. And I know it's the booster exploding, and I know eventually the booster will not explode, but in terms of a spectacle.
What the hell? What a shot, Jack. That's amazing, dude. Bada boom. Yeah. Big bada boom. Yeah, remember, from the rocket, remember?
Here we go.
Yeah, Mac, I think they packed enough. I think they packed enough explosion, man. Jeez. Oh my god. That's so insane, dude. I think there's enough. The reason why we keep saying that, if you're not familiar, the reason why we keep saying it is because on the first flight, they didn't pack enough. The booster goes up and it starts flipping end over end, and they trigger the flight termination system and they pop, and it didn't destroy it. They underestimated how strong their own freaking rocket was. And now, let's be real. That's a no-no in spaceflight. Don't do that. So I think they overcompensated a bit. That was a lot of explosion, man. That's why we're saying, yep, I think it worked. I'm pretty sure that worked. Yep. Very Project Highwater. right? Yeah, I'm pretty sure they let all the freedom out right there. Yeah, well, yeah, exactly. Olmar's, that's a good point. Well, now you know that that's enough. Now you know that's enough C4.
Go at throttle up.
Is it safe to ride? Meow, does that look like it's safe to ride on?
Wait for it.
I wouldn't want to be on that. I don't think you would either. It's gone to plaid.
That's one of the most beautiful things I think I've ever had a camera pointed at.
That's really freaking cool, man. I don't know. It looks fun.
Discovery, go at throttle up.
Oh yeah. You can ride on the next one, sure. What? One thing is certain. Yeah, quick one-way ticket. Yep, to the underworld. Yes. Ludicrous speed. Go! You must have hyperjets on that thing. What do we got on this thing? A Cuisinart? Or to the overworld. Yeah, I mean, pick your afterlife. The wise word of Adam Savage. Well, there's your problem. Prepare ship for ludicrous speed. They went ludicrous speed. They got very close, actually. Yeah, no, you're too tall, Meow. Sorry. But if you do ride it, it'll make you shorter from the, from the G-forces and stuff. It migrated to the quantum realm. Phil, what's this? Damn, that's cool. Here's a shot from Elon's brother, from Kimball.
Oh my god. Man, that looks amazing. Whoa.
Alright, this might get loud here real quick. This might get loud. Headphone users. It's gonna get loud in probably about the next 5 seconds.
Sound. Feel it.
That's really cool. That's impressive. Like a freight train, baby. So something that I'm kind of noticing, it looks like they're running fuel rich, which the fuel indicators on the telemetry would show that. See the trail?
Oh my god. Oh my god. Oh my god.
Oh my god.
Wow.
Man, that looks amazing.
I would say it's the film cooling, Phil. They're running fuel rich to make sure the engines don't pop. Yeah. It does come out. It's pretty cool, right? When do you think we'll see the WB-57 camera? Not sure. Can I pet the dog? Yes. Yeah. Oh, absolutely. That's wild, man. That's wild. 35-story building flying into space. That's a skyscraper being launched. It's pretty cool. Trajectory estimated by Jonathan McDowell was 1740 by 150. Yeah, that's definitely an off-nominal trajectory, mate. That's not what Kate said during the cast. That's, yeah, something went weird with the trajectory. Just got an alert that it was lost. What did they mean? It was a test flight, Twizzle, so losing the booster in the vehicle is not that big of a deal. Here, let me show you. Let me show you what the part that SpaceX was really looking to get right. Here, let me just refresh the video. Was this part right here. Check this out. This was really the big deal with IFT-2, getting this part right. Thermodynamics do be like that, meow. So watch. Here, I'll turn the audio on.
And acquisition of signal Houston and New Orleans.
See, engine chill down.
Booster engine cut off. Stage separation.
Oh. That is something else, man. You gotta be kidding. That's wild. I can't believe they nailed that on the first try. That was the first time they ever tried to do that. So this is called hot staging. Basically what happens here is, in order to simplify your separation mechanism, all right, so an easy way to separate the first stage from the second stage is to light the second stage engines while the first stage engines are still going. That way you maintain constant acceleration, and your rockets are used to separate you from the first stage. The rockets on the second stage are used to separate from the first stage. You can see the rocket engine is on right there, and the plume is shooting out a vent cap on the sides called a hot staging ring. Hot staging basically means, because you're using the rocket engines, which already exist, which you're already going to need to get to space, to separate it, you can save a lot of mass. You save a ton of mass, actually a couple hundred, not 100 tons. You save a couple tons of mass in separation systems here. So this was the first time SpaceX ever did this. I mean, you can see clear as day, they have 6 engines on Starship lit and 3 engines on Super Heavy lit. That's freaking impressive, man. That's impressive. They nailed it. They got it. It was on the first try. That's unbelievable. I thought it would have blown up. I thought it would. Well, it did. Yeah, I thought it would have blown up earlier. Let me put it to you like that. I thought it would have exploded earlier. Hey, Jared. Do you get a significant amount of bonus delta V because you're pushing off the first stage as opposed to nothing? You not because you're pushing off of the stage, Cartesian. That's a good question though. You don't gain delta V. But what happens is you actually, because you're constantly accelerating, you don't incur a grav loss at staging. So, you know, a Falcon 9, for instance, they shut down the first stage and the vehicle's just coasting for like a split second. They separate it, right? And then fire the engine on the second stage. That period of time where you have no engines flying, gravity is slowing you down. You're not accelerating because there's no engines on. So maintaining that constant acceleration that you get during hot staging actually saves you. I would say it saves you delta V, right? Because you don't have to work as much because you're constantly fighting against gravity. You don't incur that grav loss from deceleration during staging. That, and it's way simpler. It's way simpler. Hot staging is a much simpler thing than like Falcon 9 with all of its pneumatic separation systems, right? But hot staging is a lot harder to do. Just because it's simple doesn't mean it's easy. In fact, the most complicated engineering is often really simple concepts, right? but that doesn't mean it was simple to engineer. Hot staging is difficult because you're firing your rocket engines at your first stage, and especially if you're trying to reuse it. It's time to wake up. Step 1 in KSP is hot staging, right? Yeah, right, Faye? Yeah, you're not wrong. You're not wrong. That's my alarm, dude. Time to get up. Actually, that's the late alarm. I'm usually awake by now. Oof. Would SpaceX face fines for these failures? Nope. No, this is why it took so long. So Irish, that's why it took so long between the first and second test flight to take into account in case stuff like this happens. Yeah. But fellas, here's the thing. The launch license was approved, obviously, because they launched today, but it's not just for this launch, it's for further launches. Right? It's for further launches. So we should, Jeb willing, we should see another Starship launch sooner rather than later. I'm saying instead of like 7 months till the next one, maybe 3 at the maximum. SpaceX has another one teed up. They have another Starship and another Super Heavy ready to go. Is it because he bought Twitter instead of fuel? Well, no, it had enough fuel on it. It had enough fuel on it. Depends on the pad, though. It might have taken some damage. Well, actually, I think the last thing that I'll do here for the coverage is let's see what our boys over at NSF are up to. Pad looks to be intact. I mean, you can't tell. It's hard to say, but everything seems to be all right. Well, oh yeah, Mikey. I saw what Mikey was saying earlier. Yeah, it definitely broke some things. So you see there's these metal shrouds on the sides. Oh, no, it's fine. I was going to say it looks like it blew the shroud off that staircase, but the staircase is right there. It's good. Yeah, that doesn't look too bad. Tanks in the background, those were dented from the IFT-1 flight, believe it or not. They might be they might be a little bit more dented, yeah. Maybe. How's Hoppy doing? I think Hoppy is fine. Why did it explode? Epic. It exploded. The explosion was triggered by what's called an AFTS, Automatic Flight Termination System. So basically, the reason why the booster exploded is because they didn't get all the engines to relight for it to do its boost back, and that pushed the vehicle out of its track. So if you think about like a flight corridor. So if you around the launch pad think like a I don't know, 100-meter radius around the launch pad, and you build it like there's a cylinder around the pad. That cylinder is its flight track. The flight track is, well, just that. It's the track that the rocket should take going up into space. Now, don't get me wrong. It's hard to get it exactly centered in the track. This is where guidance systems come in, right? Like rocket guidance systems are super advanced to be able to self-correct in case like the wind blows it offline a little bit, right? So that track goes all the way up into space, okay? If the vehicle, now for the first stage, there's also a track for the boost back trajectory. In Starship, there's a track for all the way into space, right? The automatic flight termination system understands where this track is, okay? It knows that if the rocket at any point goes outside of this track, it'll blow it up. That's what happened with the booster. Because they didn't get all the engines to relight, the booster didn't follow the track, and once it went outside of its nominal trajectory, it exploded. They triggered the computers triggered the flight termination system on board. Now, Starship, I don't know. I don't know why that thing popped. They did not get to the velocity that they needed. Main engine cutoff was 30 seconds early. That's way too early. Way too early. That's... Yeah, that wouldn't... Even if the thing had coasted, it wouldn't have made it all the way to Hawaii, and that's probably the reason why it popped. Now, why did the engine shut down early then? Well, the computer could shut down the engines if the engine started doing something that you didn't want, or if it moved you too far out of the track. Now, there are correcting systems, right? There's a correction system on board, like the thrust vector control. The computer will command the engines to point in a different direction, and that could steer you back. But there isn't a whatever happened, it clearly didn't like it. And once again, 24,000 is not enough. That's not enough. Actually, it might be close. If it was a high suborbital trajectory, it might be enough, but it's hard to say. I think from the telemetry, Ivan, that it looked like there was a cutoff. Either that or the engines popped. The ship had a hydraulic thrust vector control. Mm-hmm. Will today delay Artemis 3 further? No. Unlikely. But anyway. That was pretty sweet, dudes. It's pretty awesome. NSF stream at T plus 2650. You could see some burning stuff coming into the camera. T plus 2650.
On the ship, disconnects, and then it starts rising 2 seconds later. It's amazing.
Discovery, go at throttle up.
I have...
Do you think the silver bullet will fly next? Maybe, Hells. Yeah, Amos, 57 months. Yeah, guys, this was a test flight. Very important to understand. It was a test flight. If it popped, that's fine. But I will say this, and this is why I was so confident that this vehicle would get a lot further than IFT-1. You learn the most from doing this type of testing. You learn the most from hitting the send it button. Now, here's the flip side of that coin. Hitting the send it button is expensive. But SpaceX has a lot of money. Let's just say that. But you do learn the most from it. It is expensive testing like this, doing iterative testing, because losing flight hardware sucks because it takes a long time to make rocket motors. Spacecrafts are very, very complicated. They take a long time to put together. It's like IKEA furniture, but worse. And it could blow up if you get it wrong. Think about that. You don't want your Marcus chair popping in your face if you didn't put it together right. That would be terrible. Rocket science do be like that. Think about that. So, this way you learn the most, but you do lose flight hardware, but SpaceX doesn't give a frick. Nothing is stopping what's coming, you know? So, they have another one teed up, and I guarantee you that IFT-3 will get further. You know, SpaceX is really trying to buck that trend of spacecraft being hard to put together, and the way they're trying to buck that trend is by trying to mass produce them. Good luck with that. And I say good luck, and I actually mean that. That's not... If you can figure out how to mass produce these parts that are complicated to make, well, good on you. EJ, watch the launch until they switch feed on NSF. It passes Hoppy on the right side. Okay.
I think you can see
Thank you, Nova. I appreciate the support. Wow.
And you see a number of them because you do have these engines lighting up in not all at once, right? They launch them in a sequence, so you're going to see multiple shockwaves there.
Begs the question, why didn't all the engines light or the specific engines work? That is really the question for the flight termination system to terminate. I'm going to guess, Epic, that it probably had to do with six Raptor engines blowing the top off of the Super Heavy or damaging it in some way and not getting the right propellant feed. That's what Shiva said, so I'm pretty sure Shiv is right. He has the telemetry in front of him. Fall Pelts, 43 months. Thank you. Razlak with an 84. Sam Carr with a 51. What's up, guys?
Look out for the... If we replay it again, obviously, look out for the quick disconnect arm. It separates, and then 2 seconds later is when the liftoff happens. So the QD
Small F.
On the ship disconnects, and then it starts rising 2 seconds later. It's amazing. Look at that.
I have
Woohoo!
something special coming. Apparently, we might have some footage of a booster explosion.
Wow.
Also in the pipeline. Just teasing that. We are working on it.
Okay.
Yeah, all rockets kick up some dust like this, guys. It does happen.
So many cameras.
We just see it with SpaceX. You know, I mean, there's
have
clearly
so
some
many
stuff there,
angles.
but
You really don't want to miss what's coming over the next.
yeah, that was the staging footage we saw because we're not teed up with live. That's freaking impressive, dude. Raven Guard, my guess is propellant feed, but I don't know for sure. I mean, I'm making that assumption based off of what I heard from Shiva during the cast. He said that there was some damage to Super Heavy during hot staging. Uber Monkey, bell overpressure? I don't know. No, I don't think so. Raptor engines are cleared for way higher propellant or way higher chamber pressures than most motors. Like I said, it's probably propellant feed, dudes. But we don't know. Your guess is as good as mine. Wild. Freaking wild. What a day. That's unbelievable, man. It's so cool to see.
The photographs from.
I was going to say, do they have the audio? But no. That's terrific. There is some... Rockets do kick up a lot of dust. I missed it. What's the rundown? This is the part you want to see, Josh. Watch.
Engine power continues to look nominal on 33 Raptor engines. We're about to shut down the first stage and perform staging.
All 33 engines worked. And they worked pretty damn well, dude. No engine out on the first stage. Here's the kicker. Watch this, dude.
And acquisition of signal Houston and New Orleans.
Booster engine cut off. Stage separation.
Frick me, that's cool. Oh man, that's wild. That's so freaking cool, dude.
You're hearing the cheering.
That's awesome.
Hot stage for SpaceX's Starship.
Oh my goodness, that's impressive.
Incredible views of our
Bye-bye.
super heavy booster.
Nope.
And as you can see, the super heavy booster.
That part's kind of cool too, but also, yep. Why is it called hot staging? Good question. Hot staging means, so normally when a rocket stages, you shut the first stage engines off, you have some type of separator system, and then you push your second stage away, and then the second stage turns on and fires. Hot staging is when your first stage engines, you shut down some of your first stage engines, but keep some of them on, so the vehicle's constantly under acceleration, and you fire your second stage engines while still attached for a split second. That's what you just saw. Now, hot staging is complicated. It's a hard thing to do because you have rocket engines firing at your fuel tank on your first stage. That's not ideal. Now, SpaceX does have deflectors inside of the first stage there, right? To shoot the second stage exhausts off to the side. You'll see it happen in a second here. But also, you're still firing 6 rocket engines at a methane tank, at a gigantic methane tank, so it can cause problems. Drone shot. Okay. I got it. So, watch. So, you see they start commanding engine shutdown. Note that the engines are shutting down from the outer ring first and going to the center, right? Let me back it up just a little bit. Watch. Watch, they'll start shutting them down in sequence. They'll start from the outside, and it'll go in patterns. Watch the shutdown sequence. Ding, 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 ding. And then, right there, second stage engines are firing, first stage engines are still on. This way is complicated, but it is the simplest way to separate your first and second stage. Why is it the simplest way? You already have the rocket engines. You use what you already have to get to separate. You don't need a separation system, so you can save mass that way. Why didn't they use explosive bolts this time? Well, the system is supposed to be reusable, T, and you don't want explosive bolts. And that's the first stage. The first stage never shuts those 3 Raptor engines off until the boost back burn, but they didn't get that far. Just in, haven't looked yet. On a scale from 1 to 100, 100 being success, how much of a fail was this? 76.33 repeating, of course. Pretty damn successful. Hot staging was the big line item there. All right, let's check out that footage. So we got a drone shot from Elon there, and then, oh, another drone shot here. Yeah, I think Elon was just, okay, here. Wow. Wow. That's pretty neat. Is this the same one? Let me see. Yeah, this is from the cast. So that's the same shot, but the shot over here is uninterrupted. Why is it this color? Well, you can tell it's that color because of the way it is. What color? There's a lot of colors on the screen, Starge. You're gonna have to be more specific than that. Dude, look at the clouds. See the clouds flickering? The sound is perturbing the clouds because it's so loud. You can actually visualize the sound waves because of the pressure differences. Look. Oh. That's how you know something's loud, when it's physically changing things around you and you can see it. So they're running fuel rich. That's what I was thinking. See all that? It's unburnt methane. They're doing that to keep the engines cool, which tells me that these engines were very conservatively limited. That's a lot of extra fuel being dumped overboard. That's okay. It's fine. It's totally okay. Like per environmental and everything, that's fine. It's okay. A lot of rockets do that. A lot of planes do that. What passing said, Fearless? That's freaking impressive, dude.
Discovery, go at throttle.
Hey, Roundabout, what's up, man? Tilted at launch and then auto-corrected. Chief, a lot of vehicles do this. A lot of vehicles tilt like this right off the pad. In case something goes wrong, you're very unlikely to come right back down on the pad. True story. I know, nervous. How about the overpressure event, dude? Guys, watch down here. You'll see a pressure wave come out from when they light the 33 engines. It looks like a freaking mushroom cloud. Like a, see? Oh, that's cool. Yeah, most rockets, Chief, do that. We just don't really see it because not every rocket gives you a drone shot like this. Falcon 9 does this all the time. Every rocket does it. Even the space shuttle to an extent. I mean, the space shuttle did that power slide, so it kind of happened just inadvertently, right?
Discovery, go at throttle up.
So, we just don't really see it too much. They do this in case something goes wrong. It'll come down next to the pad and not on your multi-million-dollar launch pad. Hey, RJ, thank you. Thank you for all the tips. I appreciate it. The liftoff from the pad world looks like it's much better than the first launch. Shows the power of the engines. Well, they changed the ignition sequence, dude. They lit the engines at T-6. At this time, the ignition sequence start happened at T-2 seconds. They went from 6 seconds to 2 seconds, which is crazy. Okay, RJ, will do. Thank you for the tip. A group of us saw Gwen afterwards, and she said, "Insanity prevails." That's awesome. What a legend. Could them running rich be a possible reason for orbit being short because of less power? We'd have to look at the staging timeline, Mutter. You'd have to compare the actual cast to the planned staging timelines. If main engine cutoff was a little late, or a little early in this case, then yeah, maybe. It's a possibility. Clark, you see that, Clark? That's a resub. Now see that? That's a space RV right there. And they do have hyperjets on it. Link to this clip. Say please. I'm just kidding, man. I got you. See that there? That's an RV. That's a space RV. What's this? What's the smoke? Fuel rich in our... That's unburnt methane coming out of the engines. My guess is that it's there for cooling reasons. That's a lot of unburnt methane coming out. But, once again... Look. Okay, so Shinar, I know you know this. This is for everybody else. Rocket engines often run very fuel rich. You spray way more fuel than you need into the rocket engine, right? And the reason why you do this is because some of the fuel, all the fuel that's there combines with all the oxidizer and explodes. And then there's some extra fuel. That extra fuel absorbs the heat from the explosion, and it ends up making the engine run a little bit cooler. This is one of the tricks that rocket scientists and rocket engineers employ to make sure that your rocket engine doesn't melt. Running extremely fuel rich is what's going on there. I can tell you that right now. Now, why are they running fuel rich? They're probably running fuel rich because they don't want 33 engines to explode, or have something happen like on the first flight. They're probably very conservatively tuned. They probably tune them in a way that they know is going to make them work, and that's it. They'll probably squeeze more performance out of Starship as we see more test flights. But running conservative parameters on your test is very, very, very... That's normal. That happens. That's my guess. I don't know for sure. I don't work for SpaceX. That would be nice. More fuel is more mass, no? Yeah, of course it is. NASA's response. How do I know restricted? Self-taught, dude. I've been just doing this for a really long time. Yeah, I'm also a nerd. Yeah, big nerd. But yeah, I'm self-taught. I read way too much about this because it turns out that a lot of people want to know how rocket science works, and a lot of people don't know how rocket science works. So recognize the need. So this is the head of NASA here right now. That's Bill Nelson, Senator, Representative Bill Nelson. Congrats to all the teams who made progress on today's test flight. Spaceflight is a bold adventure, demanding a can-do spirit and daring innovation. Today's test is an opportunity to learn and fly again. Together, NASA and SpaceX will return humanity to the moon, Mars, and beyond. And if you think I'm doing an impression, no, that's Bill. That's what he sounds like. No, not Bill Clinton. Different Bill. Different Bill. You're talking too fast. Pudding man. No, that's cool. I'm really happy that NASA's gung-ho about this. But NASA also needs their lander. Yeah, Bill's the old school Florida man. How long till they can land the whole thing like Falcon? Well, it's going to take more flight tests, Shixap. We're a little ways away from that. What would Dr. Z say? Dr. Z would say that this is very good. This is a very good launch. The telemetry that was learned from this will be the data that was learned here will be able to enrich us scientifically for decades to come. I miss that guy. I miss that guy. I really wish he'd come back. Me too, Chief. Me too. What would Dr. Nutbutter say? Mein Gott. Just keep playing this audio on a loop. You got it, Hot Toddy. That seems to be a lot less, wrecked. Pad looks healthy. Yeah, it looks okay to me. Now we're on an impressive tangent. Yep. How would Spock characterize it? Probably... It's illogical to lose your launch vehicle, but the data that was ascertained from it would be tremendously helpful. Use the Force, Harry. I think Spock would say that. Yeah, Bips, the booster... They made it to hot staging, the booster was doing a boost back, and it exploded. And then Starship was almost to orbit, it was very close, and then it too exploded. But hey, getting to the staging was the really important part. And the pad seems to be okay. No, just fascinating. Oh yeah, goalie, for sure. You're a wizard, Luke. Yoda said that, I think. Wizard you are. No, this one was better. It was pretty damn impressive, Element. I gotta run. Hope you, Brimo, have a great time in Florida. Happy Thanksgiving. Yeah, you too, man. You too. Thanks again for all you do. No problem, Brendo. Yeah. You're a pod racer, Frodo. Gandalf said that. Get it right. Ah, oh, yeah, my bad. Sorry. You're a pod racer, Frodo. NSF is showing the pad. The tanks are damaged. All right, let's switch over and see what our boys over there are saying.
Starship were destroyed by the flight termination systems, but it did not result in a failed mission here. I think everything that SpaceX was hoping to achieve was achieved, and the FAA, who was very nervous about the flight termination system not working on the first mission, now saw it operate not once but twice. And we have some spectacular views that we'll be sharing with you of the flight termination system engaging on the booster, which was unbelievable there, so pretty cool.
I just want to point out that Jack is quite literally in a shipping container somewhere near Boca Chica doing this webcast. Just want to point that out. I think I think there's something tremendously funny about that.
The very near future. So just a crazy day here.
No studio.
So
shipping container, dog.
No
studio.
Had more engines working.
Shipping container.
Sorry.
Jack? Yep.
I think Jack is like staring at us.
Well, so much for that. Jack is frozen. Just. Oh, shipping container. Nope, the shipping container studio didn't work. I jinxed it. That's hilarious. Oh my goodness. Oh, that's pretty funny. I'm looking at the NSF back channel. He put up a picture while he goes out and collects debris. Oh, okay. All right. No, EJ, no, that is so not right. If I were him, I'd totally set that as my no signal screen. Nice. Oh, of course, you woke up 50 seconds before it launched. Awesome, dude. What a freaking day. What a freaking treat. Dude, can I... excuse me. Can I... Do you guys mind? I just need to... I need to learn how to read. Just... Twix. Wow, that's pretty cool. Staying up for Vegas tonight, Dak. Actually, I gotta start packing. I gotta get on a plane. So, fellas, this is where I'm gonna wrap it up.
Discovery.
And whoa, XTC gifted 10 subs. Thank you very much. Oh, damn, dude. Thank you. You guys have been too good to me. To only put it to you like that, but it does go. It's very much appreciated. Thank you. And with that being said, I'm gonna take the money and run.
Go and throttle up.
Oh, come on, take the money and run. So, guys, I am actually taking this week off. And I'm going down to the Cape. Actually, yeah, going down to the Cape for Thanksgiving. So, once again, all the subs actually really helps because the next stream here, unless there's a Starlink launch, just saying.
Discovery, go and throttle
up. Unless we do an IRL stream. The next stream will be cities. We got to finish the highway stuff, which that's all I'm going to be thinking about all freaking vacation. But I'm going to be back on the 27th. So actually, I got to start getting ready to go. Turns out, you got to pack down the house and stuff, make sure all the trash is out, do adult things. It kind of sucks. But, hey, it is what it is. Part and parcel, I suppose. So, thank you very much for watching, everybody, and thank you very much for the support.
Discovery, go and throttle up.
I'm flattered. I'm flattered that even after all these years, people still aren't tired of me. It's kind of very humbling. So, thank you. Happy Thanksgiving, everyone. Yeah, absolutely.
Discovery, go and throttle up.
No AJ for a week. I'm sorry, man. I stacked the VODs this week. I made sure we did super long streams so you guys would have something to watch. Also, hi VOD viewers. I did like a bunch of 11-hour, 12-hour streams this week so you'd have more stuff to watch, right? I think about that stuff. I haven't forgotten about you guys. I do appreciate you. Yep. If you can't watch live, I understand, but I do appreciate it. Thank you. So, I'm gonna head out. No, guys, I'm gonna...
Go and throttle up.
I gotta go. I gotta start getting ready. Not impressed. It's still funny, but I can't believe that guy. Anyway, so thank you very much for watching. I'm truly grateful. It really, really means a lot. I know that's what everybody said. Oh, thank you, everyone. Yeah, no, I really mean it. I'm gonna, you guys have definitely shown up, and guess what? When I come back, you're getting my A game. We're gonna hit cities hard. There's a couple of other games that I want to mess with, and we got Kerbal. We got the Kerbal Exploration expansion, or patch, I should say, or edition, because it's early access, right? That's coming out in December. So, December's, we're hitting it guns blazing when I get back. So, I do appreciate it. Did we hit 400K? Tall, I didn't get it. We're at like 396, dude. So, thank you very much for watching, everybody. I do appreciate it. I'm going to head out now. I got to go get ready. So, Have a happy Thanksgiving. Thank you very much. Enjoy your break. Thank you, guys. And I'll see you. Oh, man, was that cool. What a treat. What a freaking treat. I'll see you guys in a week, okay? Thank you very much for watching. Raid? Okay, hang on. You guys want to raid? There's a lot of you. Let's see. Let's raid. Who's out and about? I don't know who streams at this hour, because it definitely ain't me. My buddy Jim is playing City Skylines. So for all the Cities viewers, my buddy Jamori. No. We'll raid Jim.
Slow the trains down.
Dude, listen to this, dude.
Sharper turn.
Listen.
We'll save space. Or the old one, yeah.
Jim has the best radio voice around. So we're gonna go raid Jamorian. He's a good dude. He's playing Cities. He's a pretty damn good Cities player. Right? He's been playing Cities as long as I have. So go see what Jim's up to. And I will talk to you guys in a week. Thanks for watching, everybody. Have a good night. It's not nighttime. I'm just used to saying that. Have a good day. I'll see you in a week. Thank you.